Hey everyone! Today, we're diving into the world of data encryption. You know how we lock our doors to keep our homes safe? Encryption is kind of like that, but for your digital information. It's all about protecting your sensitive data from unauthorized access. Think of encryption as transforming your data into an unreadable format, like a secret code. Only those with the right key can unlock and read the information. This is crucial in today's digital age, where data breaches and cyber attacks are becoming more common. Whether you're browsing the web, sending emails, or storing files online, encryption plays a vital role in keeping your information secure. From your passwords to your bank details, encryption acts as a shield, safeguarding your privacy and giving you peace of mind. So, buckle up as we explore the fascinating world of data encryption and learn how it works its magic. Alright, let's break down how encryption actually works. It's a fascinating process that keeps our digital communications secure. Imagine you want to send a secret message to a friend. You wouldn't want just anyone to be able to read it, right? You wouldn't just write it down in plain English, right? That would be too easy for someone else to intercept and understand. Instead, you'd probably use a secret code that only you and your friend know. This way, even if someone else sees the message, they won't understand it. Encryption works in a similar way. It's like a digital version of your secret code. It uses complex algorithms to transform your readable data, known as plaintext, into an unreadable format called ciphertext. This transformation ensures that your information remains confidential. This ciphertext looks like gibberish to anyone without the decryption key. It's designed to be completely unintelligible. Here's a simplified explanation of the process. Let's break it down step by step. 1. Plaintext. This is your original readable data, like a message or a file. It's the information you want to keep private. 2. Encryption algorithm. This is the mathematical formula that scrambles your data. It's a set of rules that dictates how the plaintext is transformed into ciphertext. 3. Encryption key. This is the secret code that unlocks the encryption. It's a piece of information that determines the output of the encryption algorithm. 4. Ciphertext. This is the encrypted unreadable version of your data. It's what you get after the encryption algorithm and key have done their job. To decrypt the message, the recipient needs the correct decryption key. Without it, the ciphertext remains a mystery. When applied to the ciphertext, the key reverses the encryption process, transforming the gibberish back into readable plaintext. This way your friend can read the original message just as you intended. Now let's talk about the different types of encryption. Encryption is a crucial aspect of cybersecurity, ensuring that our data remains confidential and secure from unauthorized access. There are a few different ways to encrypt data, each with its own strengths and weaknesses. Understanding these methods can help you choose the right one for your specific needs. Symmetric encryption. This type uses the same key for both encryption and decryption. This means that the same key is used to encode and decode the information. It's like having one key that can both lock and unlock a door. This method is straightforward and efficient, making it ideal for situations where speed is essential. Symmetric encryption is fast and efficient but requires a secure way to share the key. If the key is intercepted during transmission, the security of the encrypted data is compromised. Asymmetric encryption. This method uses two keys, a public key for encryption and a private key for decryption. The public key can be shared openly, while the private key is kept secret. Think of it like a mailbox. Anyone can drop a letter in the public slot, but only the owner has the private key to open the mailbox. This ensures that only the intended recipient can read the message. Anyone can drop a letter in the public slot, but only the owner has the private key to open the mailbox. This method is highly secure, but can be slower due to the computational power required. Asymmetric encryption is more secure but also more computationally intensive. It is often used in scenarios where security is more critical than speed, such as in secure communications. Hashing. Unlike the other two methods, hashing is a one-way function that transforms data into a unique, fixed-length code called a hash. This code is unique to the original data and cannot be reversed to retrieve the original information. It's like taking a fingerprint of your data. Just as no two fingerprints are the same, no two hashes are the same for different data. Hashing is used to verify data integrity, ensuring that the information hasn't been tampered with. If even a single bit of the data changes, the hash will be completely different, indicating that the data has been altered. Each type of encryption has its own use cases. Symmetric encryption is often used for encrypting large amounts of data quickly and efficiently. Symmetric encryption is often used for encrypting large amounts of data, such as in database encryption or file storage. While asymmetric encryption is commonly used for secure communications like SSL/TLS for websites, this ensures that data transmitted over the internet remains confidential and secure. Hashing is widely used for password storage and digital signatures. When you create a password, it is hashed and stored, so even if the database is compromised, the original password cannot be retrieved. In addition to these methods, combining encryption techniques with other security measures such as multi-factor authentication can provide an extra layer of protection. This ensures that even if one security measure is breached, others remain intact to protect your data. Encryption isn't just some abstract concept. It's everywhere in our digital lives, working silently behind the scenes to keep our information safe. Whether you're aware of it or not, encryption is a fundamental part of the digital world we navigate every day. From the moment you wake up and check your smartphone, to the time you go to bed, encryption is at work. It's the unsung hero of our digital age, ensuring that our personal data remains private and secure. Here are a few examples of how encryption is used in the real world. Let's start with online banking. Online banking. When you access your bank account online, encryption protects your sensitive financial information from prying eyes. Every transaction, every balance check, and every transfer is shielded by layers of encryption. This means that even if someone intercepts the data, they won't be able to read it without the proper decryption key. E-commerce. When you make an online purchase, encryption secures your credit card details during the transaction. This ensures that your payment information is safe from cybercriminals. Every time you enter your credit card number, expiration date, and CVV code, encryption is there to protect it. Messaging apps, end-to-end encrypted messaging apps like WhatsApp and Signal, use encryption to ensure that only the sender and recipient can read the messages. This means that even the app providers can't access your conversations. Your private messages remain private, giving you peace of mind when sharing sensitive information. Virtual private networks, VPNs. VPNs create an encrypted tunnel for your internet traffic, protecting your privacy, especially on public Wi-Fi networks. This is crucial when you're using a public hotspot, like in a coffee shop or airport. With a VPN, your data is encrypted from your device to the VPN server, making it much harder for hackers to intercept. Password managers. Password managers use encryption to store your passwords securely, so you only need to remember one master password. This not only simplifies your digital life but also enhances your security. With a password manager, you can generate strong, unique passwords for all your accounts without the need to remember each one. These are just a few examples of how encryption is integrated into our daily lives. From protecting our financial transactions to securing our online communications, encryption plays a vital role in keeping our digital world secure. It's not just about keeping hackers at bay, it's about ensuring that our personal and professional lives remain private and protected. So, the next time you use your smartphone, shop online, or send a message, remember that encryption is working tirelessly to keep your data safe. It's the invisible shield that guards our digital lives.